Hi there, it's Jason Gorman from Codemanship here with the third video in our series on test-driven development in C#. If you've not watched the previous two videos, I highly recommend you take a look at those first. There'll be a link to the series in the description below. In this third video, we're going to be asking the question, what should we test? Now, in test-driven development, when people are quite new to it, they often will start by thinking that they should be writing unit tests for every unit, in inverted commas, in their code. So every class, every public method, and so on and so forth. And I want to illustrate why I think that's not such a great idea using the simple business example. We have a requirement for a CD warehouse. So we sell and ship CDs from a warehouse directly to end customers. We've got some very, very brief requirements here from our customer saying that they need to allow their customers to buy CDs from the warehouse. They need to be able to search for a CD on the title and the artist. And we need to be able to receive CDs from the record labels into the warehouse so we can add stock. So very, very simple requirements. And based on those requirements, we might do some upfront thinking about design. Now, nobody has ever actually said in test-driven development that you don't do any upfront design. No one has ever seriously suggested that. In fact, many of us think it's a good idea to have put a bit of thought into, okay, well, how is this actually going to work before we start writing tests, before we start writing code. So maybe I read these requirements, and based on these requirements, I come up with a design. Let's take a look at a class diagram here. I'll just enlarge that for you. Based on the concepts that I think are involved in these requirements, a little bit of upfront thinking. So we have a CD with a title, an artist, and a price. We have a method for buying a CD or quantity of CDs. We have a method for checking the amount of stock for that CD. We have a catalog in the warehouse, and we can search that catalog on title and artist. And the warehouse has a method for receiving batches of CDs. And we can see all the classes involved here. Now, a classic TDD mistake is to do a design like this up front and then start thinking, okay, well, I'm going to need to test that we can get the stock count. So maybe we write a test for the constructor of a CD. So let's imagine that we do that. And I'm using NUnit 3, by the way. Let's write a test method for CD is created with initial stock. And what we're going to be testing here is that when we create a CD, let's write our assertion first and work backwards. That if we create that CD with a stock of 10 copies, for example, based on our original design there. So what I'm doing here is I'm writing a test based on that design for some features of that design. So let's imagine that we have our CD, okay, and we're going to create that. So what we're testing here is a combination of a constructor and a getter. Let's create that type, CD. Okay, there we go. And we need to create it with a constructor. Let's say that's the initial stock. Let's get rid of that. And now let's create that getter. Okay. And we run this test to make sure that it fails. And hopefully we get a practical failing test. There we go. So yeah, our test is failing because the test assertion is failing, so it's a good test. And we can very, very simply make this pass by, for example, if we had a private setter for our auto property here, and then we could set that in the constructor. So this is what we call an obvious implementation. So we're just going to write the code to pass this test rather than triangulating towards it with multiple test cases because it's very trivial. So there we go. The test is passing, and that's all good. It is technically test-driven development. We wrote a failing test. We wrote simple code to pass that test, and we'll probably do a bit of refactoring in a second as well. But here's the thing. Why does the CD class have a constructor that takes initial stock? Why does the CD class have a stock count? What is that for? And this is the point that I want to make. These are details of an implementation design. They're not outcomes in of themselves. If we go back to our requirements, there's no mention of any of this really. There's no mention of, oh, customers want to be able to create CDs with an initial stock count and then be able to query that stock count so they can find out how many copies there are. Not mentioned here at all. Why do we need to know the stock count? It's very, very simple. We need to know the stock count for when users perform actions that change the stock count of a CD. For example, when we buy quantity of a particular CD, we would expect that stock count to go down. So we're tracking the stock count. In other words, we have this stock count getter, this property on CD, so that we can check that buying a CD has actually worked. It is a consequence of a more meaningful test. And that's the first thing we're going to be talking about. Meaningful tests. Meaningful tests are about outcomes, useful behavior that end users or customers require from the software. They want to be able to buy a CD. They want to be able to search for a CD. They want to be able to send batches of CDs to the warehouse. So we need to be able to receive those batches. So we find that it is better to drive your designs from tests that are about outcomes, like buying a CD or receiving batches of CDs, and let the design details, the classes and the constructors and the getters and the setters, let those take care of themselves. So in other words, we're coming up with an implementation design that satisfies the customer's requirement. And the details of that design are, well, this is the simplest thing we can think of that will actually satisfy that requirement. So when we do it this way around, when we come up with an implementation design and then start writing tests for every part of that implementation, that is the cart leading the horse, if you like. That's the wrong way around. We need to drive it the right way around, which is our tests need to be about outcomes, outcomes that our customers, our end users actually require from the software. So write tests that are meaningful, that are about outcomes, and let the design details, like the classes and the constructors and the getters and the setters, let those naturally fall out of passing those higher level meaningful tests. So point number one we're making today is to write meaningful tests. The advantage of doing this way is we end up with the design that we need to pass that meaningful test, the simplest design that will give our end users what they want. And as I said, I've done this design and it's probably right, but the devil is in the detail. And I'd rather let the test-driven development design process drive out those details than try and decide all of those details up front. Now, I'm balancing this with the advice that it's not wrong to think about designs up front, but it is a bad idea to think about detailed designs up front. It's a bad idea to basically try and do the whole design in your head or on paper and then start writing tests, because then you get into what I call design-driven testing. So it's not test-driven design where we're coming up with simple designs to pass tests. Design-driven testing is when we're writing tests based on a design or a preconceived idea of what the design should be. And that often leads to what we call speculative generality. That is, we often start to sort of gold plate our solution. And it also usually leads to a lot more tests and a lot more test code. So for both those reasons, one, because we don't want to end up with thousands and thousands of very, very low-level tests about constructors and getters and setters and all that kind of thing, but also because we want to come up with the simplest design that will give the end users what they want, it is better to start with an idea of what the end users want and drive our tests from that. Which brings me to my second point. Let me just delete this bad test. We don't need this test because the next test we're going to write is going to make this redundant. So let's make some space there. Right, let's go back to these requirements. Now, like I said, it is a good idea. People do recommend, who've been doing TDD a long time, that you do actually think about things up front. And one tool that I found useful for thinking about the software up front before I start writing tests is what's called a test list. A test list is a pattern that is described in Ken Beck's excellent book on test-driven development, by example. A link in the description below if you've not had a look at that book yet. And basically, it is quite literally just a list of the tests that we think we would need to pass in order to satisfy this requirement. It's as simple as that. Now, it doesn't have to be an exhaustive list, and we don't have to think of every possible test case necessarily. The idea is it's going to serve as a as a thinking exercise, as a bit of upfront analysis, but it's also going to serve as a roadmap for the work that we're going to be doing. So it's going to say, well, we're kind of going in this direction, and it will allow us to plan the tests that we're going to write and the order maybe that we might write them in. But also it allows us, as we cross each of these tests off, to track how we're doing in terms of the work. So let's think about this requirement or this set of requirements. We've got three use cases here. First of all, we've got a use case for buying a CD. And I can think of two test cases that we might need to tackle here. There's the happy path, when there is enough stock, basically. And when there's enough stock, then the quantity is deducted from the stock. So I'm just thinking out loud there. That's the test scenario, and that's what I think will happen. Okay. But what if there's not enough stock? Well, maybe there we might throw an exception. Okay, maybe. So we're having a little think about what are the test cases and what is the software actually going to do? Okay. Now, that I think is okay for buying a CD. Those are roughly the two that I can think of. What about searching for a CD? Well, again, the happy path is that the CD is in the catalogue, in which case the CD is returned. What if it's not in the catalogue? In which case we return nothing or null. So it's not been found, basically. And finally, what about receiving a batch of CDs from a label? Well, we might need to think a little more about this. So first of all, maybe it's a batch of single CD that we already have in the catalogue. In which case we'll add the copies to that CD. Stock count. What if it's not in the catalogue? Okay, in which case we'll add the CD catalogue and add copies to stock count. And what if it's a batch of multiple CDs, some of which may be in the catalogue, some of which maybe not. So CDs not in catalogue added and copies added to stock count for each, I should say. So we've got a bunch of test cases there that we might need to work through in order to satisfy this requirement, to give our customer what they want. And what we do is we say, okay, well, let's start here, for example. You would normally prioritize. So I like to start with the most important test case. And I think selling CDs is pretty important. That's the whole point of our business. So I would often go for that first. So you would go for the test case that has the most value, or you would go for the test case that's the most interesting, or that's going to raise the most questions about architecture, for example, or something that we don't know how we're going to do it yet. So you would prioritize in that kind of way, come up with your list of tests, and then start working through them. So rather than starting with a test for the constructor of a CD and checking it's created with the initial stock, we would write a test for buying a CD when we have enough stock. So let's write that test first. Void enough stock. Writing our assertion and working backwards. What we're saying now, what we're saying now, let's say we created it with 10 and then we buy 1 copy. So then at this point, we're deciding that we need to check the stock count of the CD. So we make a design decision that says we need that property, but we're doing it so that we can write this test for buying a CD. So the test, the higher level test for buying a CD, is forcing us, is driving out the details of the underlying design. So let's declare our local variable for CD here. Let's imagine that class exists. Okay. Declare that class. And declare it with stock count of 10 to begin with. So we've got 10 and we're going to buy 1. And then at this point, again, the test tells us, oh, we need to be able to construct it with an initial stock number. So the test is telling us this. We're only doing this because this is required in order to pass this particular meaningful test. Okay, now let's create that property for stock count. Lovely. Let's get rid of these not implemented exceptions. If your tool allows you, I would recommend switching that feature off, that auto code generation there. And hopefully now when we run our test, the test will fail because the stock count is actually 0. Okay, let's just check. Yeah, I was expecting 9, but it's actually probably 0. As we can see there we go. Okay, now, stock count can be an int, that's fine. So we do the simplest thing to pass this test. What we can do here is, well, let's imagine that we have a set. So again, I'm working backwards. We can have a private setter here. Now we run our test. Oh, interesting. That's because we haven't actually bought our CD. Silly Jason. That's the bit we have to add. We have to buy 1 copy. This is why we pair program, by the way, or mob program, so that when I do silly things like this, people can point it out. Let's generate that method now. Let's get rid of that not implemented exception. Let's run our test. Okay, now calling it I for now. We'll change that name when we refactor. So now our test is passing. Let's just rename that. So here's the thing about upfront design. The names that I'm choosing for these things are based on features of that design. They're based on this. So the thinking that I did, the bit of upfront analysis and design that I did before we started coding, it is useful because it puts me in mind of concepts that I can use in my code. And there are lots of different ways of doing this. It could be, for example, rather than doing a class diagram, we could just take the text of the requirements and run them through a tag cloud generator and then print that off and stick it on the wall. And then when we're saying, well, what should we call this method here? Well, let's call it buy, because that's the word that appears in the requirements. And what do we call this parameter for this method? Well, they're buying a quantity of CD. So let's take that word. So it is useful to think about the design up front. But as you've seen, the actual details of the implementation design are all a consequence of me testing that line of code there. So that constructor is a consequence of, well, how do we set it up so that it has copies that we can buy, so that it has stock? Well, let's use a constructor. And that line there, again, well, how do we check what the stock count is? Okay, well, we'll need some way of getting that from the CD. So we're making design decisions based on what will we need to test that that buy method has worked. The test is meaningful because it's driven from the requirements, not from our preconceived idea of the design. But having said that, having some preconceptions about the design, particularly in terms of the domain language, the domain concepts, can be very, very useful as we're making decisions about what kind of things we need and what to call those things in particular. So upfront design does help us to write the tests, but it's very important that when we're writing our tests, that we're being driven by useful outcomes. We're writing meaningful tests that are not about the details of the implementation design, which is going to lead to a lot more tests, but that are about actually achieving something for our end users, achieving an end user goal. So, write meaningful tests. Test lists can be very, very useful. We can just tick that first test off now. Well, let's just put a cross next to it. Okay, we've done that one. And then we would move on to the next test. Let's just illustrate this. So our next test is for when there's not enough stock. Not enough stock. And what we're saying here, let's write assertion first and work backwards. What we're asserting here is that what should we call this exception? Insufficient stock. Okay. Now let's declare that down there. And we probably need to make that an exception. Okay. And now we're gonna put in a lambda here that's going to trigger this. So the lambda here is when we try to buy more copies than we've got. So if we've got 10 copies, let's try and buy 11 copies. Working backwards from here. There's our CD. And we're going to create that with an initial stock of 10. So not enough stock, basically. New CD. I keep thinking I'm working in Python. Okay, and let's run our tests and see what happens. Hopefully this will fail because it's not throwing that exception. Okay, we're expecting that exception and it's not happening. So this is a pretty easy one to pass. Again, it's a trivial, it's an obvious implementation. If quantity is greater than the stock, then we're going to throw an insufficient stock exception. So there you have it. That's two tests. So we're working our way through our list, and then we would move on to writing tests for searching for a CD in a similar kind of manner. As we're working, it may well happen, it often does, that as we're writing the code, we'll think of other test cases that we might need to handle. That's absolutely fine. All you do is add those to the list. Don't break the flow of what you're doing. If you're working on searching for a CD that's in the catalog and you suddenly get, but what if there are multiple matches of artist and title, which can happen, then don't get distracted by that. Just add it to the list and carry on working on the current test that you're working on. Get that test working, one thing at a time, basically. It's a very, very useful discipline for a software developer. Get one thing working at a time and then just add it to the list. So they can be very useful in that sense as a kind of a roadmap for where we're going with our test-driven process. So we've actually looked at three things in today's video. First of all, we've talked about why it's better to write meaningful tests, tests that are about outcomes, and let those tests drive the implementation detail rather than planning implementation details and then trying to write tests for every part of the implementation. We've seen how a test list can be a useful roadmap, as well as being an upfront kind of analysis exercise to make us think about the design more. And we've also looked at how some upfront design can actually help us as we're writing our tests, particularly when it comes to choosing the names for things. So thinking about the concepts and the requirements is very, very useful. And finally, and you may not have noticed this, there was one other thing that we talked about. In both of these cases, I did something that I haven't really done in the previous two videos. If you go back and watch the first video, you'll notice that we took very, very small steps when we were writing code to calculate totals for a shopping basket, for example, rather than just write the code to calculate the total for a list of items. What we did first off was to say, well, the simplest case we can think of is an empty basket. And then to pass that, we just have to return 0 because that would be the total for an empty basket. So we triangulated that first design, one test case at a time, making it more general with each new test case. In this example, I just went straight in and wrote the general solution. So we've got a field for stock and we just return stock. Yeah, there you go. Or, okay, we just check to see what the stock is, and if there's not enough, then we'll just throw an exception. These are what Kent Beck in his book calls obvious implementations. There's not much value to triangulating it, working through a series of test cases to implement a feature that is very, very simple, to pass a test that has a very, very obvious implementation, like adding two numbers together, or adding an item to a list, or returning the value of a field. Those obvious implementations, you would just write them. You wouldn't triangulate them. You wouldn't work through a series of test cases for returning the value of a field. You would just return the value of the field because it's very, very straightforward. All of these three things taken together, writing meaningful tests that are about outcomes, not design details, using test lists that are driven directly from the requirements as a roadmap, if you like, and writing obvious implementations when it's really straightforward, not triangulating, they tend to lead more experienced test-driven developers to writing fewer tests. And one thing I've noticed when I mentor people in test-driven development is when they start, they've written tests for everything. So they do an exercise like the Mars rover Kata or something like that, and you get to the end, they've got dozens and dozens and dozens of tests. And then you go and look at their production code for the project they're working on, and there are thousands and thousands of tests because they're testing everything. They're thinking, oh, I'm going to need a test for that getter, I'm going to need a test for that method, or maybe I should make that private method internal so we can write tests for that, and so on and so forth. So the tests are testing every little part of the design, and they end up with many, 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 many very low level tests. Not only does this mean that you have to support a lot of test code, it also means that your test code is very tightly coupled to your internal design. It's coupled directly to the details of the design, which means the test code is going to be a barrier to changing that internal design going forward. But it also basically means that you've just got a lot more test code. More test code means that it's going to cost more to maintain that test code. And if test code is difficult to maintain, then you've got a problem, because that means that you're not going to find it easy to change the logic of your implementation without having to rewrite lots and lots of test code. Okay, so that's all about what should we test. We write meaningful tests. We can use test lists to basically act as a roadmap, and also as an upfront analysis technique, a very simple technique to make us think more about the design and where we're going. And when the implementation is obvious, we just write the obvious implementation. We don't need to necessarily triangulate through a sequence of examples. We can just use that one example and go, well, that's the implementation. But that comes with a warning, which is sometimes things seem obvious, but it turns out they're not. So err on the side of caution there. General rule of thumb is if you're not sure, triangulate. Start with the simplest example and then just maybe return a hard-coded value to begin with. Take smaller steps the less confident you are. But beware that less experienced developers tend to be overconfident. So if you've not got much experience with TDD, maybe take smaller steps. But as you gain experience, you'll find that you can take not bigger leaps, if you like, but you can take more confident steps, which often leads to less tests. Okay, so that's video number 3. I will see you in video number 4.